Welcome to our workshop on risk mitigation with software composition analysis and dependency management. Very happy to see that many people joined the workshop. The FASTEN H2020 project, so it's a big EU-funded research project. I'm Sebastian Bocksch. I'm assistant professor at the Software Engineering Research Group here at TU Delft and the scientific coordinator of FASTEN. And in this role, I have the pleasure to host today's workshop and welcome all of you warmly to our event. FASTEN is in the last year of development. It's the end of the project is in December 2021. So we thought it's the right moment to reflect on our current results and on the future of the field. I think like many of you probably have heard about this workshop through the Dependency Management Dev Room that we organized at FASTEN, the second time already, actually. Like we also organized this room last year. Given the success and the positive responses that we have received there, we thought it's probably a good idea to like organize this workshop to feed basically this interest in the topic. It's also interesting to mention that at FASTEN we collaborated with the software composition analysis dev room, and I mean obviously there's a close link between the two topics, and as such I'm hopefully happy to eventually welcome Michael Jäger to the workshop, who is also giving a presentation but not yet in the audience. Overall, we will have 5 great presentations today, 4 from several of the members of the FASTEN consortium, and one, as I said, by Michael Jäger, who's part of the software composition analysis community. And we got in contact with him through FASTEN, and he will be elaborating on his vision on how the future management of bill of materials will look like. I would like to formally mention that the session will be recorded. So if you don't want your name or face or voice be recorded, then please don't speak up or rename yourself in the chat. And speaking about the chat, if you have any kind of questions or any kind of clarification that you need, please use the chat for that. Then we can, like, as a moderator, we can like pick this up and clarify this, and maybe even like merge some questions. In general, we will try to keep the Q&A part after each talk to like simple clarification questions, so we can like first cover all the talks, and then in the end we have a more exhaustive Q&A where we hope to have like an open discussion with everybody. The Q&A session in the end will roughly probably take like 15 to 20 minutes or so, if I remember the schedule correctly. Yeah, the overall event will end at 5:30. So I think it's a good time to actually start with the presentations, and we'll make sure that we stay in time in the end. The very first talk will be given by Cedric Thomas. He's the CEO of OW2. They are basically the brain behind the marketing and the publicity strategies of FASTEN. And he will talk about the market background that basically determines the adoption rate of the FASTEN technology. So without further ado, please, Cedric, go ahead.
So yeah, we thought it'd be interesting to start this webinar by sharing with you some trends and figures about FASTEN's market background. Of course, after that, you will go deep down into the technology. So the first market, of course, is that we are interested in is the open source market. FASTEN belongs to the open source software market, and it's the main backdrop of what we do, the main business backdrop of what we do. And it's currently estimated at some 210 billion euros and growing at over 22% per year. So that's, I mean, depending on the estimates. And that means we have a very dynamic market. It's probably one of the most dynamic segments, one of the dynamic segments in the IT industry. With that, open source is definitely mainstream. Several studies or several angles can prove that. What you have on your left is the result of a study by Red Hat that identifies that already 86% of CIOs identify using open source as a sign of being innovative. So the collusion between innovation and open source software is something that is already quite well recognized. Another study, and it's a picture that has been quite popular from a study by Sonotype a couple of years ago, shows that in any given application, 80 to 90% of the code is already written, is already reused, and there is only the rest that is a genuine code. And reusing the code is, most of it is from open source components. And that does not go without some challenges. A study by Tidelift has identified 3 key remaining challenges, such as the risk about how well the package that somebody will reuse being maintained, concerns about the licensing or compliance, or the IP compliance. This is a whole area that has that is attracted the attention of open source software users or reusers. And there's also the identification and remediation to software vulnerabilities that can be imported through reusing components. And at the same time, the Gartner Group recommends that comprehensive visibility into the open source and commercial components and frameworks used in an application of services must be considered a mandatory component. So this is really something that is highly recommended to all CIOs, and we cannot blame the Gartner Group for being open source activists, but they recognize that, and they really recognize to use technologies and tools. And users need new tools, and this need for new tools is precisely the market opportunity for software composition analysis. They need new tools to select and manage open source components. So this componentization of software, the rise of open source, and the need for being able to manage all these this ecosystem of software, this is what is the bedrock of the software composition analysis market, and that goes in 3 main directions. Of course, managing vulnerabilities, managing IP and compliance, and also managing the quality and possible defaults imported through reusing components. So that's the software composition analysis market today, evaluated at some 250 million euros, or so 200 million euros. It is still growing at over 22%. So it's not a huge market, but it's still pretty much significant at the global level, growing very fast. And it is a market that is served by 20 to 30 competitors. Many of these competitors, as you can see here, are small competitors. There are many pure play SMEs. They are developing their own technologies. Many of them have a priority on security management and compliance management, but they're all gradually developing tools, methodologies to help users handle reusing open source software. So among these companies, we have, I said, a handful of pure play SMEs. There are also many, well, quite a few IT giants in the IBMs and Microsoft of this world are also looking at their own code base. And talking about code base, this is the market that is also determined by the hierarchy in languages, where you see that from the index, from the Popularity Programming Language Index, it's an analysis from almost a year ago now, but it shows that Python is probably the most popular language, with 31% of the searches on Google. That's the way the index is built. Then followed by Java, 18-20%, so 30-20%. You have almost half of the languages with Java and Python, and then there is C and C++. So that's what is determined, and each of these languages have their own package management systems to which dependency management and component management tools have to connect with, and we are specifically looking at Maven, PyP, NPM, and NuGet, and no official package management for C and C++. So that's how we frame the business or market background for the FASTEN technology. And as of today, we have identified 4 key go-to-market strategies, if you like. Well, basically, today, what we have identified is a free plan for usage and running on workstations. Premium plan with a little bit more sophisticated analysis. Then there is the hosted plan, where the compute resources are significant and are provided by the FASTEN platform. And then there is the private or OEM plan, where the FASTEN methodology, the FASTEN tools methodology are used, embedded in a more broader methodologies by a partner. So it could be OEM. And this is where we see that we have on this market competitors that can provide alternative to what we do at FASTEN. But since we evaluate that FASTEN is an enhancement to existing technologies, we expect that many of these competitors will also be partners to the FASTEN technology. So we are conducting a market survey at the moment to identify the best go-to-markets for FASTEN. There is a questionnaire at the end of this webinar. Please fill in this questionnaire. It's about the webinar, but please let us know if we can contact you later to evaluate further and discuss further this innovation and go-to-market strategies for the FASTEN technologies. And that's all for me. Thank you very much.
So thanks, Cedric, for the nice presentation. Are there some clarification questions that we should quickly cover, or should we just move on to the next speaker? Antoine Moutier, he's a software engineer at heart, also working at OW2, and he's very active in programming, especially in the Java ecosystem and on open source software. And he will give a demonstration of the FASTEN dependency management tool that we built on top of MAME. So Antoine, please, the mic is yours.
Hi everyone, I'm Antoine Moutier, OW2 CTO, and in this presentation I will try to give you an overview of FASTEN project and try also to have a quick demonstration to show you what are the first results of the project and how we have been able to integrate FASTEN feature into Maven. And hopefully also I will be able to answer your question at the end of the presentation. So we'll start with an overview of the current situation. What are the tools already available? What are the known limitations of the tools available? And then I will dive into FASTEN, trying to give you an overview of the solution, speak a little bit about the architecture of the solution, then move on to the demonstration. And at the end, I will try to mention the few limitations that might still exist and also answer your questions. So let's start with the way we build software nowadays. So when you build a new software, you always reusing. At least you will reuse some low-level feature of your operating system. You never start from scratch. You reusing file system features, you're really reusing drivers, but you're also reusing most likely some standard library feature from the programming language you are using. And you also frequently use third-party libraries. So it's really helped to build software quickly. You are reusing a lot, so you don't have to create something that already exists. So an application will be something like that. You have your code and you declare some dependencies. Those dependencies will be the direct dependencies, and they have themselves again some dependencies, what we call transitive dependencies, and it can go on and on. And a dependency can be at the same time a direct dependency from your code and a transitive dependencies from another library you depend on. And we'll see that it might be an issue when you have this kind of situation where a dependency is both direct and transitive. We'll see that in the demonstration. To help you with the libraries, dependencies management, you have toolings that exist, build tools such as Maven for Java, PyPy for Python, and for C programming language it's a little bit more specific, but in the context of FASTEN project, we use the Debian repository as a source of dependency management. And all those tools come with this central repository, and they will take care of downloading the libraries from the central repositories and also resolve the potential conflict in the different library you depend on, because, for example, you might have dependencies, a dependency on a single library, but in different version. So it's part of the job of the build tool to deal with that. And it's crucial because as you have dependencies of dependencies and so on, the graph of dependencies can start to become huge, especially with the latest software development where the framework are bigger and bigger. This can lead also to other issue. For example, if a library that was published on a central repository is removed from this repository, it will break your build. It's what happened, for example, with LeftPad when it was removed from NPM. And also a very frequent situation is when one of your dependencies, either direct or transitive, have a security issue. You need to monitor that, you need to be aware of that, and you need to take action to fix that. If you don't do it, you are exposing your user to security issues, and it can have important consequences, as we've seen, for example, with the Equifax issue. To help you, there is already some toolings that are available. You have central source of information regarding security issues. You have toolings such as Dependency that will look at the dependencies you declare in your software and suggest some updates based on security issue. You have toolings like your continuous integration that will be there to help you. To do continuous build includes a merge request automatically generated by the tools. So you already have some toolings available. The main issue with the currently available tooling is the lack of accuracy. Actually, the tools look at dependencies at package level. They don't go into the details of what function, what method are actually called. This can end up with some false positive. For example, in a situation like this where an application calls a library that itself calls the library, and it will only use a subpart of this second library here. For example, here we have an unused function. If an issue, a security issue, for example, is reported on this function, current tooling would tell you that you need to update because they only see them at the library level. This is where FASTEN try to improve that, because it will build this code graph and will get the information, will locate the information about security issue, but also license issue, risk, and so on at the level of the function. So FASTEN builds a code graph, gathers the data to be able to provide more precise information, and so to give more precise indication and suggestion to the developer. So for example, it will not tell you to update your library even if a new version fixes a security vulnerability if you are not impacted by this code because you don't use it, because you only use a subpart of a library. This is an overview of the FASTEN architecture. So to build the call graph, FASTEN will need to get the library, the binary version of the library when you do dynamic generation of call graph, and you also need to do to get the source code when you do static generation of call graph. So you will get the dependencies both from the central repository such as Maven or PyPy, but also get the source code, for example, from GitHub. Once the call graph is generated, it will add all the metadata to the graph, and it will get information for publicly available sources such as the CVE, and it will store all those information, the information it extract from the source code like license information, in database. So there is two different kind of database. One graph database to store the call graph, because as you might guess, this is kind of huge in terms of volumes, because you have a lot of dependencies in public repositories like Maven and a lot of function, of course. and it will take all the metadata to a PostgreSQL database. And then from the end user perspective, it will be able to interact with FASTEN using a website that will be able to show information about the dependency is using, but mostly the interaction between the developer workflow and FASTEN will happen through build tools like Maven or pip that will query the REST API of Maven to get information like call graph, annotated call graph from FASTEN server, and report information about the project the developer is building to pinpoint a potential issue in his project. And of course, as a build tool is called by continuous integration server, information can be reported back to the user in the CI reports. But now let's jump into a quick demonstration where I will try to show you how FASTEN can help to detect and prevent issue when upgrading a library. What are the impact of a library upgrade? So for this demonstration, I have a very basic application. It's my app here that calls mylib in version 3.0. It's called a function that have one parameter that is either true or false to put the message in uppercase or lowercase. And it calls also a proxy function in myoslib that itself also called say hello, but this is a different function, a different signature of the method, but still it's a library in version 3.0. So if I move to my development environment here, you can see that I have the dependency on mylib in version 3.0 and myoslib in version 1.0. And here I will actually build that, so build should be successful. You can see the source code over here. You can see the call to say hello here and the call to the other library here. And build is successful. And I can as well run the application. And right now in the current situation, everything is just fine. The application built successfully and execute successfully. Here it display two messages. Now let's say that I want to use a new feature of my library, so I want to move to version 4.0 here. So I'm upgrading the version and moving to my source code here. I will call the new method here that's have as parameter the first name of the user. So again, I will build this application, and you will see here the build is successful. This new method is available in the new version, so no problem. But if I try to execute the application, here we'll see the problem, because the problem is not directly inside my code, it's in the dependencies that is using the old say hello method that was removed actually in this new version of the library. In version 4.0, so we have one addition, is the method say hello with a string, but we have one method that was removed. It was a say hello here. And so myoslib that depend on version 3.0, actually only version 4.0 was available because the build tool here, Maven, have to choose only one version, and it pick the latest one here, 4.0, creating this issue. And we see the issue only on runtime. So hopefully if you have integration test, you might figure out this with a test, but if the integration test doesn't cover this part of your application, you will only see the issue when you ship the application to your users. So here FASTEN can help. I will enable the FASTEN plugin here, and the plugin will generate a call graph for the application, and based on the call graph analysis will be able to warn me about the issue I have. So let's build again the application. And you will see here among the logs, you will see that the FASTEN plugin is being executed, and it generates call graph for my project. So it will generate call graph for what is available locally, but if I have dependencies to third-party libraries that are available publicly, it will be able to get call graph directly from the FASTEN server. And now if I'm moving down here, you can see that it reported me that the callable here cannot be resolved. So the function that is called by my other library is not being resolved, and so the build failed. So instead of failing at runtime, now I'm failing at build. So this really should help the developer to detect a problem earlier. And as you know, the earlier you detect the issue, the less it costs to fix it. So that was a quick demonstration of FASTEN. The same kind of feature will help you to figure out if you are impacted or not with security issue, and also with license compliance, risk management, and so on. So there is a lot more on this very quick demo. So I invite you to constantly get back to the FASTEN project and monitor anything new that can be released with the future version. So I thank you all for your attention, and if you have questions, I will be happy to answer them. Of course, you can learn more about the FASTEN project on the official website. Also find out about the source code on GitHub, report issue, get in touch with us, also follow us on Twitter. Thanks a lot.
We just move on to the next speaker. Thomas Mortain, he's the lead dev at XWiki and involved in a large number of open source projects. And yeah, he will talk about the FASTEN user experience from a software vendor perspective in the future, like how XWiki plans to use do extension management in the future using the FASTEN infrastructure.
So hi everyone, I'm Thomas Mortain. Like Sebastian said, I'm a lead developer on the XWiki open source project for XWiki SAS, which lives from professional support, hosting, and other kind of services around the XWiki project. And XWiki is participating to the FASTEN European project as a user of the tools produced for the FASTEN project, and also as a developer for the Maven plugin, which, as you saw, works great. Looks like we still have some work to do. In this presentation, I will talk about XWiki and how XWiki is not much currently, but planning to use FASTEN tools, as they are currently coming to an age where we can actually think about using them and putting them in actually released XWiki versions. So I will start with a short presentation of XWiki to give a bit of context, and the part of XWiki which really interests us in this talk is going to be XWiki Extension Manager, and then the use cases in which XWiki plan to use FASTEN tools, which are the builds of the FASTEN Maven plugin, and various improvements to XWiki related to FASTEN feature, like compatible filtering of search, being aware of the risk you have in your instance of XWiki, and searching for various XWiki specific information in the extension provided by FASTEN. So first, XWiki, as the name would suggest, is an advanced wiki used in big teams or small teams, but it's mostly a wiki with a few more features that you will get the common WYSIWYG, wiki syntax, of course, the possibility to manage rights, depending on the wiki page you want to access, the space, all that. Also, several wikis, and responsive skins for mobile access, and an advanced search, because wikis, as everyone knows, are usually a mess, and you really need a good search to navigate it. But XWiki is also, over the years, became what we will call an application platform, because the wiki concept has also been applied to the development of applications. Because in wiki pages, you can put scripts, you can put structured content, like you would in a database, for example, defining columns and types, and use various script languages to produce dynamic wiki pages, but also full-featured application and complex application that will reuse components, API, and a lot of things you can install using the XWiki extension manager. So the idea behind the XWiki extension manager is that any sound application platform need a package manager like you would have on any, like you have Maven for the Java ecosystem, you will have the extension manager for XWiki ecosystem. There's already a lot of extension you can install, but more importantly, you will want to create your own extension, and then you need to indicate what kind of library, like kind of over extension you will depend on, and a lot of things that you need to give in the metadata to create an application like we do now, like Antoine explained. You always need to reuse a lot of pieces. So right now with the extension manager, you can install jar, so standard Java jar files, web jars, which are Java files but actually containing JavaScript and CSS. XAR, which is a format specific to XWiki, which contain wiki pages, because you can export, import, and since I explained before, since you can have script in wiki pages, most of the UI of XWiki extension are actually wiki pages. Of course, empty types like POM, in which you don't have any associated file that you can use to list the dependencies. But over the years, people also implemented extensions to inject NPM packages, Python packages in XWiki, because you can leverage the Java scripting API to execute those. So the first, let's say, not in hierarchy, but in timing, the first thing XWiki is going to use from FASTEN is the Maven in the XWiki Maven plugin. Right now, XWiki has quite a lot of dependencies. So you can see here the numbers, and it means we very often have to upgrade to keep up to date. Sometimes it stay a bit behind because we don't know how to upgrade because it causes conflicts, and also mean that there's probably issue we don't know about within that the tools like the Maven plugin of FASTEN is going to help us find before someone hit it in runtime and doesn't really report it or work around without telling us, or maybe it's going to be a very, very important bug that go through to the release, and we only know about it after the release. So it's very important that we get as much tools as possible to give us every little bit of issue we can find in the build. And we already use a lot of those, but the FASTEN tools is going to give us quite a few more information, like the already known security vulnerabilities that might be in one of our dependencies that we don't know about, because while we do look at, we do monitor important dependencies of XWiki, core dependencies of XWiki that we directly depend on, we don't always know what those dependencies are going to have as transitive dependencies. Maybe they did a mistake and they themselves don't really know about it. One important thing when you upgrade so many dependencies very often is that we often have the use case detailed by Antoine. When we use a new version, a good example is Guava, which is not very strong on the retro compatibility front. And when you upgrade it, you very often can cause issue with other dependencies, expecting method that has been removed or which are just modified. And so from Java point of view, they don't really work anymore with the old dependencies. And another thing that we also monitor in our direct dependency, and we trust them, but it might not always be accurate, is the licenses. So XWiki is using LGPL 2.1. So it means there is some licenses like GPL that we can't have as dependencies. And while we try to be careful, and we probably don't have the issue with direct dependencies, maybe one of those dependencies has the same issue, and they wasn't very careful with it. Another interesting thing that FASTEN will bring is validating some quality metrics on the dependencies we use. So I'm not sure exactly which level of quality we could request, for example, during the build, but it's an interesting metric that we could experiment with. So in the XWiki runtime front, when the first thing we worked on, and which has been implemented already for the most part, is through the FASTEN index, the FASTEN central server, we get a lot of information coming from various repositories, for our various artifacts gathered from Maven repository mostly, even if FASTEN Central is also doing other things than Java. In our case, it's the main concern. We needed to implement a local index gathering all and listing all those extensions and everything we can know about those extensions, like the known risk coming from FASTEN, the known class and method, and also XWiki specific components that we can deduce from very fine-grained metadata we get from the FASTEN knowledge base. And from this, we can do live validation of available extensions, so that you can only see what you can actually install, what has a good chance of working in your specific version of XWiki and specific instance. For example, the version of Java you are using, the system in which it's running, etc., etc. Another important and more obvious use case for FASTEN metadata is just telling administrator of XWiki if they have known vulnerabilities in the extension they install or in the version of XWiki itself, because XWiki is publishing CVEs too. And like presented in a previous slide, in XWiki we have a lot of specific components. One of them is macros that you can use in wiki pages, and you might have use a macro which is not installed yet, or maybe you imported the page and you're in the new instance the macro doesn't exist already. Right now you get an error just telling you that just ask your admin and maybe you will know how to fix it. But with metadata coming from FASTEN, we can easily propose to install a set of extensions which all provide this specific macro. And same when you want to add a new macro in a wiki page, we could also list, right now you get a view of all the available macro, all the installed macro, but we could also add easily macro that you could find on not yet installed extension. And I will show a bit of XWiki, of a short demo, if I have some time left, to show a bit what's already there and how could look, how could future things could look like. So this is XWiki. This is a sandbox page, for example, which is a good thing to test XWiki. So you can. So this is the WYSIWYG view, and you can see that behind the scene, it's actually a wiki syntax. So list the usual list headings and things like that. So you can edit, etc. And and you can use. Okay, so here we are using a macro info. We are using various things like this. Here, table of content macro. This is very simple macros, but you could imagine any macro provided by an extension. And that's where the extension manager is coming to it. So this is the view you get when you want to install a new extension or when you want to review an extension you already installed. What we get from the new local index is that we can filter extensions. So here you see 38 extension, but that's only the extension which are recommended, which is a special concept of XWiki to filter extension of very good quality, which are very active and some criteria like this, but there is more than 5,000 extension. And here what we did with the local index is that we pre-validated all these extensions. And you can see that if you want to see all the extension, we'll get quite a lot more. This is the new version, the last version of XWiki. So it's actually compatible with a lot of extension. But if I was using some version of XWiki from 5 years ago, for example, I would have a lot of less extension which are compatible with it. So the nice thing is that you don't see anymore when you use XWiki LTS, for example, which is a bit older, you won't see extensions which require very new feature that only exists in the dev branch. And that was a very frustrating issue for a user. They were trying to install extension and it wasn't working. When they could install it, it wasn't really working well. Because we were not validating compatibility with what was already installed, and we didn't have all the information that we can get from FASTEN. So this is extension manager. So we can filter on a lot of metadata authors, for example. So that's all the extension I wrote for XWiki over the years, for example. I cannot click on the work tab because of okay, we try to use so here so you can filter on many metadata. So the example I told before about missing macros. So for example, when you use for example, the my macro here, but it actually doesn't exist in this instance of XWiki. So right now, what you get is an error like this. It just the macro doesn't exist. We don't know what you were trying to do. But what we can do with metadata we get from FASTEN, and we can do easily except that it's not implemented yet. So you will not get any result from the available extension. But we could easily get metadata to enrich available extension index with custom information of XWiki, like in this case, macros. And so when you also want to add new macro, yeah.
I guess in the interest of time, Thomas, do you have something that you definitely still want to show, or can we move on to the?
No, it was just the last point, the last slide. So, so here you see all the macros which are installed in XWiki, and we could easily add here a remote macro or and list all macros you could get from an extension which is not yet installed. And automatically install this extension if you are admin, or request and install from the extension from the wiki admin. And yeah, that's about it. Just the last point. So here you will see notification, so you could get notification about security vulnerability found in the installed extension thanks to FASTEN extension for XWiki. And yeah, that's about it for me.
Cool. So it's very interesting to see the use case, like for XWiki, and to see that you can actually put FASTEN to good practice.
Almost see them.
Yeah. Awesome. Thank you very much. He is the head of research at SIG. I guess we still need to unmute him, or can you do this yourself?
Thanks a lot, Sebastian. SIG, Software Improvement Group, is a company in the Netherlands. We're involved in FASTEN as one of the industrial partners that are trying to bring the ideas from FASTEN into practice. Sebastian also mentioned we're in the third year of this project, so many of the things are becoming available, as also Thomas has been showing. I will give you a bit of the context that our company is operating in, and how we are planning to integrate FASTEN technology into that. Let me go ahead. Yeah, so this is probably unnecessary at this point, motivating why we need to look into such software ecosystems. There are many examples why that is needed, and why a thing called software composition analysis, basically the analysis of what actually is in my deployed software. And so most of that is open source. Many people don't realize this. In particular, many of our clients, so SIG is operating as a consultant to management of big organizations that have a lot of old sometimes, but also modern software. And all that software relies on open source. They hardly ever know that is the case, and also to what extent. It can be up to 80% even if you start counting. So SIG, this is a little bit of a corporate slide here, but we are not a huge company. We're about 150 people spread across several continents now. We started in the Netherlands, in Amsterdam, and we now have an office in New York and Copenhagen. We're working a little bit in Asia as well. Our main business is to analyze code quality, you could say. Software quality is a bit broader. In a structured way, we have a certified approach to do that based on standards. We do this for about 15 years now, and in that time we've also extended support to quite a few programming languages, so about 280 at this point. Something we can do rather easily. Now, every year we add about 10 to 20 new languages because they also keep popping up, which is pretty nice. We measure code, so we process code also quite a lot. We have a database where we keep all that measurement work. It's about 35 billion lines of code so far, with many systems. And we don't do that for just entertaining ourselves. We measure the quality of their code to basically tell them what's wise to do, right? Is this software still workable? Can they improve their quality? Should they actually start over? Can they maybe train their people to better cope with the software? Should they introduce some tooling, stuff like that? That's the typical question that our clients ask us. Let's go ahead. Well, this I already told. I will skip this in the interest of time. This is a nice reflection of our database. So here you see on the horizontal axis, you see the size of systems we've measured, and on the vertical we have the quality, which is expressed in a star rating system that we have developed over the years, where 3 stars is supposed to be the average of the marketplace. So the average system is 3 stars. This is a thing we calibrate also yearly. So we keep that up to date with how the market is going. Why do we measure that code quality? We typically call that maintainability as the thing we measure. Here is a bit of results from a use case where this is a current customer where we're looking at a big landscape of systems, about 100 plus systems. And when we started out with them, they were not on par, let's say, with the market. Their quality overall was, we measured as 2 stars, so below average quality. They were suffering from quite a few problems you have with, if you have massive bad quality code, that people take a long time to work with it. There are lots of bugs, lots of regressions, and that simply, if you are working at that scale, it takes people time, means you need more people to do the same job, and that leads to higher costs. We are still helping them to improve that, but we're seeing some good results there. So they need fewer people to keep up that maintenance because they've managed to increase quality overall, and they do that by not only renovating and refactoring, but also simply turning off old systems and replacing them by new modern ones in modern programming languages. So SIG is not about sort of doing this in order to make corporates fire people because they're not needed anymore. Quite the contrary. So actually, that is not the way they like to reduce cost. They like to reduce cost in maintenance so that their people can do nicer things like innovate and build new software that serves their whatever their customers are better. And that is something very nice you can do if you actually manage to increase your quality. Should I say more about this? This really explains it in detail. The quality we're measuring, we've done some research on that as well to see if that is related to things like being faster, being able to put out features quicker in the market. Turns out it is. Also rates of incidents and bug fixes and stuff like that is really positively affected if you increase your code quality. Also, not to be underestimated, if you have to work with bad code all day, you don't become happy, right? So you tend to leave. You tend to want to leave, and if the code that you have to work with is beautiful and modern, that's nicer, right? So you want to stay. Not to be underestimated. All right. How are we planning to use FASTEN? So this is what I've been talking about, and this is actually a slide I will not explain in detail, but we apply a measurement model mostly on systems. So code bases that are under maintenance, under the care of a company or an organization, and in such a system, which are typically rather large code bases of maybe 100,000 to 1 million, maybe 10 million sometimes lines of code. We have tooling to analyze such systems and split them into components, drilling down to files, and in files, units. A unit is a bit of a generic name we put to a thing called a method in Java or a function in C. As we're doing this on many languages, we sort of adopted the generic terminology to refer to things. Our tooling is able to analyze that and also do connections like call graphs and call analysis across such systems, which is Yeah, there are more tools around in the marketplace like that. Our tooling does it for up to 300 languages now. We can do the star rating calculations for the maintainability that I just talked about. We also do things like cost estimation. So what does it mean if you want to change so much of your system, if you want to renovate it, if you want to replace it? We have models in place based on such analysis and quality, what it means in euros. Often that is key to the decision making in our customer base. So this is very system oriented, right? So we're looking at the code base maintained by our customers now. So what we're doing in FASTEN, obviously, is looking at dependencies. As I also said, if you look at deployed software, it can be more than 80%, or up to 80%, let's say, actual running code coming from dependencies, very often open source. So you need to look at that. If you want to talk about risks, you want to talk about maintainability, you need to include them. So we are also already doing that. There are existing SCA tools. We have also one of our own called Open Source Health that looks at dependencies at, let's say, the package level. So the things you can also find if you look at OSS index, for instance, you can find information on the dependencies you use. For us, that is already nice. However, it doesn't drill down, right? It doesn't offer the same level of analysis that we can do on a system level. So with FASTEN, we are looking into basically the main goal of the project is to drill down in dependencies, go fine grained, and also do that across the ecosystem. What you see very often is that existing SCA tools stop at the first level of dependencies, simply because if you drill deeper and you stay at the high level of packages, you get too many false positives, right? You get too many warnings about things that are not actually used. So if we consider what FASTEN offers, basically across dependency call graph analysis, you can go further down while sort of keeping precision high, right? You can know, okay, so these parts of the dependencies I'm actually using and the others I can ignore. This gets interesting if you want to consider vulnerabilities, as Thomas has also been talking about. Let's say you have a report, a CVE in a unit somewhere in the dependency. Existing SCA tools would very often say, yeah, you use that, but somewhere, right? It's somewhere in there. There's a CVE. You should probably do something about it, or not if you don't think it's a problem. So FASTEN call graph could show you, okay, there's this call graph, and it shows that actually that unit which has the CVE is not being used. You should probably still look at it, but maybe you're not urgently at risk. A similar thing could happen further down in a dependency of a dependency that you're currently not considering because it's transitive and it might lead to many false positives. But that could actually turn out to be used. But because it's in a transitive dependency doesn't mean that the code is not executed. Actually, the code is just executed all the way, all the same as the other units that sort of lead to its across its call path from here through another dependency through to the vulnerability. So in this way, FASTEN can give us more precision, but also better recall, because typically you would ignore such dependencies. Yeah, that's our main use case, and this is an example for vulnerabilities. In FASTEN, we are also building code quality analyzers for dependencies, and then we're reusing open source tooling there. Actually, a tool called Lizard is currently integrated. That is run on every dependency, and we're currently working on models to propagate such code quality results back to the system level. So what does it mean that you use dependencies with poor code quality? All right. So where we're trying to integrate it, we have an open source, I have to say, code quality platform called Secret that is meant to integrate all our tooling and it does. So you can do maintainability measurement here, security measurements, reliability, performance. These are all models that we have that we are integrating here. We're also integrating third-party tooling. So results coming from tools like SonarQube, find bugs, find sec bugs, error prone. Basically all the tools we think offer useful findings are curated by us and basically run also in the background as a service and integrated into our platform. And this is also the place we see FASTEN being integrated in the coming year. So we have a current service, I think you see it on the right-hand side here of our open source health, where there's a big matrix basically of risks consisting of licensing risks, code quality, freshness, all kinds of things you can do at the package level. And here we want to add the additional precision and recall also of FASTEN. All right, well, I will keep it short. Also have to go and fetch the kids actually at this time. So there's one thing I would still like to say. If you are interested, we are currently running a scientific survey to replicate earlier results by two researchers, Paul Rolfe and Sebastian Baltis, on software developers having to work from home all of a sudden during the pandemic. So people that made that switch and whether that impacted their work life. We're replicating that study now about a year later. So if you're interested in that and you have, well, you are a developer and you want to report on your experiences, an anonymous survey takes about 10-15 minutes. Please consider to participate. Ooh, I'll put the link in the chat as well. All right, thanks a lot. That was it from my side.
Thanks a lot, Majel, for this presentation and this nice look at FASTEN and how it can help with getting more precision and how we can drill down through all the dependencies. I think, yeah, Michael Jaeger is with us for the next presentation. So I will leave it up to you with the presentation of Eclipse SW360.
Yeah, actually, thank you for the opportunity to have the small presentation of SW360 because it's also not part of the FASTEN project. But I was wondering during the presentation I have attended that it could be maybe also an opportunity or something complementary for the developments you have made. Sorry for being late on today at 4. Actually, I don't need to pick up kids, but I have picked up kids and I landed up in a traffic jam, and that was the reason for my slight delay. So I'm one of the Eclipse project leads. If you have an Eclipse project, then there is a very structured governance model for these open source projects. And together with a colleague at Bosch, Lars Geier-Blaumeiser, we have an Eclipse project. And the idea was to provide an IT system, a web server application for a problem in software engineering with dependencies. And that's probably also related with what you do in the FASTEN project. So the original problem Lars and I were seeing back in those times is if you do software engineering, you might have a couple of software tools which deal with software components. And one of the issues that are with software components are their naming and the exchange about information from these software components. So you can have some project bill of material management, you can have code quality checks, like we have seen in the previous talk. There can be license scanning, and of course you have all these artifact repositories or package managed servers who all manage software components. But surprisingly, if you would like to exchange information or link information from one system about software components with some other system, you have a mapping problem. And that slide was actually coming before this thing of package URL was introduced. Package URL is a way of canonically define component names with their versions. But before that, all of these systems have had different approaches how to name components. And even though you were talking about the same component, it was not really obvious that different systems were talking about the components. So the simple solution is for the software components you're dealing with in your organization, is maybe have a centralized phone book with references to all the different other IT systems you have in your software engineering process. So you can link information about code quality scans and all these things in your organization. And what went out of it is a kind of bill of material management system for your products and projects. So on one hand, you have these orange rectangles, which are software components at their respective versions. And the green rectangles represent your product and or projects, your software projects. And then you just define a mapping of the different software components to these products or projects. That's basically it. That is what SW360 is all about. Take all the software components into one software repository, maybe not even the software component itself, but just having them as a record, and then denote in which projects or products they are used. And as you can imagine, you can run a number of use cases about it. It's not only about usage metrics. Some components are super interesting maybe for your organization because you use them very often. And by the way, most likely you're using a logging component very often or most often in your organization. But it's also about, for example, open source licensing. It can be about vulnerabilities. It can be about finding out how much commercial software you're using, of course. And it's very important to understand that SW360 is not for scanning. And that's the interesting part, maybe also why it is complementary to the FASTEN project. SW360 is just maintaining this catalog and managing the entries of software components for your product. Scanning, identifying all your dependencies, identifying the dependency tree, and all these things, that is done by different other tools, which I try to depict here on the right. So there's this tool Antenna, there's this open source review toolkit. There is even, for example, for SW360, an adapter for white source, because at some time, the commercial software white source was doing particularly well in understanding the bill of materials, analyzing the dependencies, and then upload it to SW360 to just have a front end for maintaining your catalog and bill of materials. SW360 has the REST API, and what happens today is that software projects are just calling the REST API and maintain their bill of material directly with REST calls. Very simple. So you get a token, you use the REST API for SW360, and then you can maintain a list of all components that you have identified during your CI runs or whatever you use to understand your bill of material. And on the other side, the REST API can be used to do more analysis, right? So you can check for new components or for new versions and do scans with licenses, for example, for Sology for license scanning. You can try to search CVEs accordingly to your components, or maybe do software quality checks on new component scans. Just to give you some idea about what is possible, I'm also working at Siemens and have the kind of IT asset management for SW360, if you know what this means in an enterprise context. So it's just providing the IT system to the users. And we have about 40,000 releases, 8,000 products, and also about 8,000 users at least logged in one time. We don't track how many users logged in how many times, but that's like the accounts that were created there. And it's a very plain, straightforward deployment, and it just runs and serves all the REST requests and all the manual interfaces. It turns out that if you think about managing software bill of material, many people think about automation and getting this list of all your components and transitive dependencies. But one important thing about SW360 is that people would like to have a front end. People would like to have a web page, a web application where they can browse to and try and then have a look on a list of components, click on the components, get more information. And that's actually what SW360 is providing to the users. It's about maybe it's fed by CI, maybe the records are created automatically by the REST API. But the SW360 provides you with a REST front end. You can do adaptations, you can deny a component, and mark it as obsolete, mark it as dangerous, and all these things. So various more information in order to run it. We have a Vagrant-based setup. Vagrant is a kind of provisioning thing together with Puppet to make a complete virtual machine that runs SW360. There's some Docker-based setup which has kind of like teething problems under course, but people also use that. And we have a lot of documentation if you check out the wiki of the Eclipse project. Maybe as an overview, SW360 has been around since quite a while. Since 2018, it has been released to the Eclipse project space. We went through a number of things with the SW360 project, for example, relicensing to Eclipse Public License 2.0. Quite lately, we did the migration to Java 11 and Liferay 7.3. That's maybe an important information. It's a Liferay application, which is an open source portal server. You could have also used Django, for example, in the Python world, but Liferay is for Java. And that's also an interesting dependency topic. If you have kind of like 100 dependencies, some of them are just not Java 11 compatible, and you need to wait until some Java 11 compatible dependency comes out before you can update your own application to Java 11. And yeah, and that's it basically. If you have heard about the project maybe on last year's OW2 event in June, what we did in the past last year is probably the client library. And the most important thing that we are currently working on is tighter integration with the open source review toolkit. So open source review toolkit and SW360 should work out of the box. If there is some questions, we can have them maybe now. And my proposal would be during the questions, I can give you just a quick look at how SW360 looks like by sharing just a different screen. And so that's it. It was just sitting there and idling. Okay. And just logging in, so that's the welcome screen. So if you open SW360, you have basically two main sections. You have projects, and that's synonymous to applications, to products, to whatever. And you have the components. This is my personal test instance. I just opened this because it is just running on my machine right now. So you have a component catalog. And the idea is actually to have maybe some metadata about the components, and then it collects the releases that you have there. And analogously, you have a list of projects and product here that you can maintain. And then you have can look in the projects here and have a look on which projects are there, what the clearing status is. If there are any vulnerabilities, of course, you need to configure it. Trade compliance is another topic which can be addressed with SW360 and so on and so on. You can export stuff with spreadsheets. That's basically the idea. You can maintain licenses. I think the system should be empty right now. And it's bringing down my laptop to its knees. You can share maybe trade compliance information, vulnerabilities, and so on. So far, that as a short introduction about SW360. I'm open for your questions, or you feel free to contact me in case you may have some questions after thinking a little bit about it.
Thanks a lot, Michael. I don't see any question right now in the chat, but as you said, we are all open for future question. So you can either drop them right now in the chat or contact us later on. I just want to say thanks again to you, Michael, for this presentation and this nice overview of SW360. And for people who are more interested also on the FASTEN project, I just want to highlight the fact that it's all open source, so you can find the source code on GitHub and the FASTEN-project organization. And of course, contributions are more than welcome, or bug reports. And also, we have currently running a beta testing campaign on support of the FASTEN project, but hopefully we'll be able to start beta testing on a more integrated product for the FASTEN project So I guess I can say that you should stay tuned for future development of the project. And just want to thank you all for your participation. And yeah, we can stay online a few more minutes if any question comes up. And that's it.